Hello everyone. So today let's solve the problem number 210 course schedule 2, right? So let's see what the question states here, right? So we are given num courses. You can clearly see here num courses is nothing but the number of courses one and the list of prerequisites as well. Yeah, we have been given the list of prerequisites as well where a comma b means we have this one. We must take the course B before the course A, right? So we must take the course B before the course A, meaning so here we have to take the course 0 before taking the course 1. Yep. So this is clear, I believe. Yep. Similar to the this one course schedule 1, right? Uh, we have to return any valid order to finish all the courses. So we have to return any valid order. Number of ways we had to return number of ways in the this one. What do we call course schedule 2? We have to check the number of ways and we have to return if it is possible, then we had to return this one. What do we call boolean value true, right? Else if it was not possible, then in that case we had to return false for the course schedule 1. For the course schedule 2, the only difference is the same question is same. We are given this one number of courses and a list of prerequisites where a comma b means we must take the course b before course a, meaning here we have to take the course 0 before taking the course 1. Yep. So we have to return any valid order. All we have to do in the course this one schedule 2 is we have to return any valid order, right? To finish all the courses. To finish all the courses. By looking at it, we can say, right, first we will take course 0 and then we will be taking the course 1. So the valid one is 0 1. Yep, it is possible. After taking the course 0 itself, we will be able to take the course 1 and this is valid, and in this case it is possible, right? So there are total of 2 courses to take. To take course 1, you should have finished course 0. So the correct course is this one. The correct order is 0 comma 1. So see here, let's come to the example 2. We have number of courses 4. Prerequisites we have been given 1 comma 0, 2 comma 0, 3 comma 1 and 3 comma 2. So this one is 0 2 1 3, right? See, there are total of 4 courses to take, right? So there are total of 4 courses to take, 0 1 2 3, right? 0 1 2 3. By looking at it itself, we have to we can just say, right? So we can just say that we have 4 courses, 0 1 2 3. So here, see, there are total of 4 courses to take. To take course 3, we should have finished both the courses 1 and 2 respectively, both the courses 1 and 2 respectively, right? So both courses 1 and 2 should be taken after you have finished course 0, meaning first we have to take course 0, then we have to go with the 1 and 2, then we have to go with the 3 in simple terms. That's what they have said here. So the correct order is here 0 1 2 3. Quite obviously, after taking the course 0 itself, we have to take the course 1. After 1, we have to go with that course 2 and 3, right? So another correct ordering is 0 2 1 3, right? 0 2 1 3 is also another order because see here, see, uh, before taking the course 2, we can take the course 0 here, right? So we have 2 0 here. Before taking the course 0, we can just take the course 2. So this comes under different category. And before we have 3 1 as well, right? In the array they have mentioned here, before taking the course 1, we have to take the course 3, right? So before taking the course 3, we have to take the course 1 actually. Yeah, so this will be 1 comma 3. So this also works here in this case, right? 1 comma this one 0 comma 2 and this one accordingly with this one. This is also the correct sequence actually. Yeah, 0 2 1 3, and we can just go with this part as well. See, this one. So before finishing the course 1, actually we have to go with the course 0, nothing but 0 1. And here if we consider these two, before taking the course 3, we have to finish the course 2. So this one will be 0 1 2 3. So 0, we can just go with the 0 1 2 3, or we can just go with the 0 2 1 3. Both are correct here, right? So we can have the multiple outputs for this particular input. Yep, don't get confused here. Let's move on with the third example here. Number of courses we have been given 1 and prerequisites we have been given null, nothing. Yep. So here in this case, we have to return 0. We can just return 0 directly, right? So this is fine. Now, yep, we have the understanding of the question. They have given us wonderful examples just for the sake of understanding. Now, let's move on with this one approach actually. So before hopping into the approach, let me tell you one thing. So let's solve this problem using topological sorting. Yeah, so we can just solve this one easily using the topological sorting, and topological sorting uses or topological sort also. Yeah, topological sort. This is fine. This uses BFS as well, right? So we'll be going with the topological sorting plus BFS. Yeah. So this is fine to solve this particular problem. Yeah, just remember this one. 1 second. Now, let's move on with this one approach part actually. Yep. So let's see. So first what we will do, let's consider first example, this one. Number of courses we have been given 2 and prerequisites we have been given 1 comma 0, right? So here we will build a graph where edges point from this one prerequisites, right? So we'll be building the this one, what do we call, similarly to the previous problem. So we'll be building the directed graph actually. So from 0 to 1, because see, I'll tell you one thing here. Before finishing the course 1, we have to finish the course 0. So first comes the 0 and we have to finish the course 1 later, right? So we will be pointing this one basically to this node actually. 1 is having the out degree, but 0 is not having, sorry, 1 is having the in degree, but 0 is not having any in degree, right? So this is fine, I believe. Nothing but in simple cases, 0 is having the out degree and 1 is not having the out degree. So this is fine. Yep. Now we will be computing the in degree of each node. Yeah, number of prerequisites for each course in simple terms. For the 0, what is the in degree? So no arrow pointing out to 0, right? Here, only pointing out to 1. So for the 0, in degree is 0. For the 1, in degree is 1 actually. Yeah, so this is fine. Yep. So now the third point here would be, we will initialize the queue with all the courses having the in degree 0. We will initialize the queue with all the courses having in degree 0. Here in this case 0. 0 itself is basically the course basically 0 is having the in degree 0 here, right? So we can just consider here 0, right? So this is fine. Yep. Now the final point is, let's process the queue here. The last point is, let's process the queue. So first thing, we will pop 0, right? So we'll pop 0, add this one to the result. So we have already this one. What do we have already initialized the queue with all the courses having in degree 0, right? 0 comes in that category. So we will pop 0 and add it to the result. So now result consists of 0. Now result consists of 0, right? So this is fine. Simple. Now what we will do, we'll reduce the in degree of neighbors, nothing but 1. We'll reduce the in degree of neighbors, nothing but 1 here, to the in degree, so that in degree of 1 becomes 0, right? We'll reduce the in degree of neighbors, nothing but 0. Neighbor of 0 is 1. We will reduce the in degree. In degree of 1 is 1 here. We will reduce this one to the 0. We will be reducing this one to the 0, right? So now the in degree of 1 becomes 0. So we will be adding this one, basically 1 to the queue along with the 0. So this becomes 0 comma 1. Yep. So now we'll add this one. What do we call? We'll reduce this one. In degree of 1 becomes 0. We'll add 1 to the queue. So we have q to the q of 1 basically. What we will do? We'll pop 1 and we'll add to the result. So this becomes actually basically result becomes 0 comma 1 actually. Yep. So this, I'll just mention this one with the result itself. Result becomes 0 comma 1, right? So the result length is equivalent to the number of courses. See the length of the result. So this one consists of 2 elements, which is equivalent to the number of resources actually. Sorry, number of courses actually, right? So the result length is equivalent to the number of courses. So we will return 0, 1 as output. We will be returning 0, 1 as output. Yeah. So this is the output. So the output that we got here is 0, 1, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct here. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. Yeah, let's quickly discuss the, sorry. Yeah, let's quickly discuss the complexities part actually. Yep. So now what will be the time complexity here? The time complexity would lead to big O of V plus E. Big O of V plus E. So why it is big O of V plus E? Here we will be traversing all the courses and prerequisites exactly once. We know this one, yeah. Accordingly with what we had discussed on the approach. So the time complexity would lead to big O of V plus E. And what would be the space complexity here? Space complexity would lead to big O of V plus E as well. So why it is big O of V plus E here? So we will be going with a graph along with a in degree array, and also along with the graph and in degree array. So we'll be making use of the queue as well, as we will be going with the topological sorting. It uses BFS, right? So basically BFS uses queue, and this is fine. Everything is interlinked. This is fine. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of B plus E and big of B plus E respectively, right? So now, as we are completely familiar with the approach as well as the complexities part, we are good to write the code. Let's start writing the code. Yep. So the first part here would be, let's go with a graph adjacency list, nothing but course to list of courses depending on it. Yep. So let me write it in this way. List of integer. Let me make this one capital I, or else we'll be getting the error. So this is fine. Let me close this one and let me go with a variable name graph. Yeah, new array list. Let me complete the syntax actually. Now let's move on with the for loop. Let's move on with the iteration part here. For I equals 0, I less than number of courses, nothing but num courses here, variable. Let me paste this one over here. Let me increment the I. Also, just add this one. Yeah, let me add this one to the graph actually. New array list. So let me complete the syntax here. So this is fine. So the next step is we have to go with the int degree array, right? So int degree array is nothing but the number of prerequisites for each course. So I'll just write it in this way. Int degree actually. So equals new int of number of courses. So I'll just copy this one actually. Let me paste it over here. Right. So this is fine, man. Now let's do one thing. Let's build a graph and fill the int degree array. So let's move on with the for loop here. So this one will be int prerequisite pre of prerequisites, right? So let me copy this one entirely. Let me paste it over here. This is fine. So within the for loop, let's do one thing. I'll just go with graph dot so not add actually. You have to get the value, right? Let me make use of the get operation here. Pre of one. Now let's add what we need to add here. Pre of zero. First one actually. Yep. Pre of zero. Prerequisite of zero. Right? So this is fine. Yep. So we are just what we are doing here. Pre of one is prerequisite for pre of zero, right? So that's what we articulated in the form of code. Now let's increment the int degree of the course, nothing but pre of zero, right? So I'll just go with here int degree of pre of zero here. Let me increment this one. Yep. So we are done with this part actually. Let me come out of the for loop. So next, let's go with a queue for courses with no prerequisites, right? So I'll just go with a queue here. So this is fine. Let me go with integer. So this is also fine. Let me go with queue. Let me assign this one to new linked list. So this is fine. Yep. Next one, let's move on with a for loop here. So this one will be int I equals 0. I less than number of courses, nothing but I'll just copy this one and I'll just paste it over here. So let me increment. So within the for loop, let's do one thing. Let's go with a simple if condition here. If let me copy this one instead of typing actually. Int degree of I, if it is equivalent to the 0, what we did if it is equivalent to this one, call if the int degree of particular node, if it was equivalent to the 0, then we added that one to the queue, right? If you remember, we added 0 first to the queue, right? So that's what I'll just go with the queue here. Queue somewhere we have made use of the queue actually. Yep. So I'll just go with the queue dot add of I. So this is fine. Now let me come out of this one entirely, the for loop. So let's go with the result array just to store the course order, right? So this one will be int result equals new int of let me pass the number of courses man. So this one, yep, let me copy this one and paste it over here. So this is fine. Also, let me initialize the index to 0. So now let's go with the BFS topological sort, right? So I'll just go with the standardized, this one, standardized BFS loop here. So not the number of courses, queue actually. While not of queue dot is empty. That's the standard, this one, right? BFS loop actually. Yep. So this is fine. Let me go with int course equals let me go with q here. Let me copy this one q dot poll of this is fine man. Next let's go with a result of index. uh Let me assign this one to the course. So this is fine. We are just adding the course to the result. Next let's move on with the for loop here. So this one will be int next of graph dot get actually. Let me pass the course actually. Yep. So this is also fine. Yeah, so within the for loop, let me go with the in degree. Let me do one thing. Where is in degree, in degree, in degree? Yep, let me copy this one actually. Let me paste it over here. In degree. Next, let me decrement this one. This is where let's go with a simple if condition here. If in degree of next actually the next node actually we have to go with the next node, right? If it is equivalent to the 0, then we'll be adding that one. We'll reduce and we'll add the next node. So we'll reduce the in degree of the next node to 0, and then we'll be adding that one to the queue, right? The same thing we are articulating in the form of code, man. Yeah, in simple terms. So I'll just go with here q dot add of next. If you remember the approach properly, the same thing, exact same thing, we are implementing in the form of code here, right? So we are left with only one step, nothing but if all the courses are added, then we have to return the result. Otherwise, we have to return the empty array, right? So I'll just write it in this way. If return, let's if the index is equivalent to the number of courses somewhere I used. Let me go here. Let me copy this one. So this is fine. Of courses, then we'll be displaying the result. Else we have to display the empty array, right? So I'll just go with a new int of 0. Yep. So this is it for the code, man. Simple one, right? So if you know the algo, actually, topological sorting, and if you know the BFS actually and the topological sorting, it's extremely easy to implement. Yeah, it's very easy to implement, right? So this is one of the simplest questions. If you know the algorithm, you all you have to know is topological sorting, how it works along with the BFS. Yeah. So that's it. The only thing that you have to know to solve this problem is this one, and you have to know the in degree, out degree, this one a graph, this one certain basic things of the graph actually. Yeah, graph definitions, in degree, out degree, bipartite graph, and this one adjacency list, adjacency matrix. Yeah, and other stuff you have to know that at any cost along with the graph based algorithms. If you don't know algorithms, so if you don't know topological sorting, so we have discussed this one Kahan's algorithm, this one on this one topological sorting, right? So that uses BFS. So if you can just go through the graph based playlist actually, in that graph algorithms are there, right? So there are many graph algorithms. Which one you want to know, you can just this one click on the video and you can just watch the video. Yeah, if you don't know, right? So yep, you can just go through the this one graph based algorithms again, and you can just start watching the video and you can just come here. You'll just understand this one quickly if you know the algorithm pretty well, right? So all you have to know here is the concepts of this one, a graph, adjacency matrix, adjacency list for this particular problem, in degree and the out degree you have to know, and you have to know the concept of this one, topological sorting along with the BFS, right? How does BFS work and along with the topological sorting. That's all you have to know, right? So this is fine. Now we are done with the coding part, man. Yep, so we are done with the coding part. So let me hit the run button. I hope this works for the sample test cases. Let's see. I have one error. This L has to be capital L. Uh, line number 14. Yep. Let me give capital L here. Wrong answer. Hmm. We are getting the output empty array instead of the 0, 1 for the first input itself. So something we have done here. Index equals num courses. This is fine. Hmm. We are displaying the result. Else we are going with a new int of 0. This is fine. So what's wrong here? Let's check from the line number 20 actually. Yeah. So here we are going with the int result number of courses. So this is fine. Index we're setting initializing this one to the 0. Fine. But not is empty. So this is fine. Int course equals q dot pose the first step of the BFS. This is fine. Equals course. We are just adding the course to the result. After that, we are moving on with the iteration part. Next, graph.get of course. So this is fine. In degree of next we are decrementing this one. This is also fine. We are just reducing the in degree of the dependent courses actually. Yep, to the 0, right? So this is fine. If in degree of next is equivalent to the 0, then we are adding that one to the queue next actually. Q dot add of next. So this is actually correct. So then what is wrong actually here? Yep, 1 second. Integer new linked list. So this is fine. So I less the number of courses I plus plus. in degree of I equals 0, then q dot add of I. So this is also Feynman. Let's move on with the for loop and pre of prerequisites actually graph dot get here pre of 1 dot add of pre of 0. So this is fine. 1 is prerequisite for pre of 0 in degree of pre of 0. This is also fine. So then where I have done the mistake, man? 1 second. So what mistake I have done here is in this one BFS loop actually. So here what we need to do basically so we have to add the course to the result, right? So we have to increment the index part to move to the next node actually. So here I have to increment this one. So now let me hit the run button. This has to work now actually. Let's see. Yeah, sample test cases are getting passed. So let me hit the submit button quickly. Yep. I hope, yeah. See here. So the code works for all the test cases, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.